Just look at the sheer complexity of a place like this. It's a whole city of pipes, tanks, and machinery, and it's all buzzing with huge amounts of energy and, let's be honest, some pretty hazardous materials. The stakes here are just incredibly high. So, what's really standing in that gap between a totally normal day and an absolute catastrophe? And that question brings us right to the heart of the problem that these systems are built to solve. It's the very real possibility that things can fail. So, what happens when the machines we rely on just don't do what they're supposed to? Okay, so here's the crucial point. This isn't about preventing a few minor hiccups or a little spill. The entire focus, the whole game, is about stopping the big one, a massive, uncontrolled release of material or energy. A single failure in just the wrong spot can be the trigger, and preventing that trigger, well, that's job number one.
So, how in the world do you do that? How do you manage that kind of immense risk? Well, the answer isn't just hoping for the best. It's a structured, proactive approach to safety. So, let's get a really clear idea of what we're talking about here.
It's called Asset Integrity Management, or AIM for short, and the key thing to get here is that it's all about the entire life of the equipment. This is not about just fixing things when they break. It's the total opposite of that. It's a proactive system. It starts way back when the gear is being designed, it continues through installation, and then it's all about rigorous maintenance to make sure every single piece is safe and reliable, from its very first day to the day it's retired. And this perfectly shows you where AIM fits into the big picture. It's part of a much larger framework called a process safety management system, which is basically the whole playbook for preventing major accidents. Think of it like a temple built to keep everyone safe. You've got your foundation, right? Commit to process safety. But look at the pillars holding it all up. Smack in the middle, under managed risk, what do you see? Asset integrity and reliability. It's not an optional extra. It is a foundational pillar holding the entire thing up. Okay, so that raises a really critical question. If we know failures are going to happen, because nothing is perfect, how do you design a system that can actually handle them? How do you make sure that one broken part doesn't bring the whole house of cards down? The answer is defense in depth. You build layers, lots and lots of independent layers. You might hear people call this the Swiss cheese model. The idea is that every slice of cheese, every layer of defense, has some holes in it. But if you stack up enough slices, the odds of all the holes lining up perfectly become incredibly small. So you start with good design, then you add control systems, then alarms, then physical things like relief valves. Asset integrity management is the system that makes sure every single one of those layers is strong, tested, and ready to go when you need it most. All right, so keeping those layers of protection in mind, let's get into the nitty-gritty. Let's look at the practical, day-to-day work of an AIM program. How does the system actually work to stop things from going terribly wrong? The system starts by focusing on what matters most. You see, not every pump, pipe, and valve is created equal. AIM zeroes in on what's called safety-critical equipment. This is the stuff that either could cause a major incident if it fails, or it's the gear specifically designed to stop an incident from happening. These are your last lines of defense. And we're not talking about abstract ideas here. This is real physical hardware. We're talking about things like pressure safety valves that have to blow open at exactly the right moment, emergency shutdown valves that have to slam shut in seconds to isolate a problem, or entire deluge and firefighting systems that have to work perfectly on what could be the worst day imaginable. This is the equipment that absolutely, positively cannot fail. So the process itself is really logical. First, you identify everything that's safety critical. Step 2, you are absolutely relentless about inspecting, testing, and maintaining it on a very strict schedule. Remember, proactive, not reactive. And finally, step 3, if you find anything wrong, you have a formal process to fix it, and, this is just as important, to learn from it, so the whole system gets better over time. And that idea of continuous improvement, that's the key. This isn't some checklist you finish once and then put on a shelf. It's a living system, a constant, vigilant process. This never-ending watch is all about constantly feeding new information back into the system. Data from inspections, lessons learned from near misses, new technologies, all to make your defenses stronger. The goal is to always be getting smarter and safer. So why does all of this matter so much? Well, sure, a good AM program makes a business run better. It makes maintenance more efficient, it helps manage spare parts, and it makes sure you're following all the rules and regulations. But let's be real. The ultimate goal,
The reason this whole thing exists is to make sure those safety systems are incredibly reliable. Because that reliability, it saves lives and protects the world around us. Plain and simple. This quote just nails it. It says it all. The mission is to make sure your safety net is always there. That term, high availability, it's a technical way of saying something very simple. When you need it, it has to work. Every single time. So we'll leave you with this thought to chew on. What asset integrity management really teaches us is that safety isn't a box you can just check off a list. It's not a project you can complete. It's a constant process of being vigilant, of learning, of improving. So in a complex world with risks that are always changing, maybe safety isn't a final destination at all, but a continuous journey.